In this problem, I have a sample of 106 men and 32 of them own cats, and I have a sample of 107 women and 37 own cats. I want to test the claim that the proportion of men who own cats is smaller than the proportion of women who own cats at a 0.05 significance level. All right, so smaller is a key word here. Less than would mean the same thing. So the first thing I'm going to do is call this the first one mentioned as my sample 1, and the second one is my sample 2. So I'm going to start out writing out the claim. Maybe I should write that. This is going to be my claim, is that P1 is smaller than P2. And the opposite then, throw an I in there, is that P1 is greater than or equal to P2. Now the one with the equal sign corresponds to my null hypothesis, and I will change that to equals. The other one then corresponds to my alternative hypothesis, and that one remains unchanged. P1 is less than P2. All right, then notice the alternative hypothesis points to the left, it's less than, that means we have a left tail test. Now to calculate the test statistic, I need a couple things. I need to know what P1 hat is, that is, what is my sample proportion for the men, and we get that simply by dividing 32 by 106. The number of successes, if we talk in our binomial terms, by the total number of trials. All right, and then we also need P2 hat, which is the proportion of women who own cats. So let me calculate these really quick. 32 divided by 106 gives me, let's call that about 0.3019. And now let's get the women. 37 divided by 107. And we'll call this 0.3458. Now there is another thing we need when we're talking about two proportions, and that is the pooled proportion. And we're calling that P bar. And to get that, I simply add these two fractions together, but in the way that you wanted to in grade school, but we're told that's not the way you do it. Now we get to do it. So I add the number of men and women who own cats divided by the number of people altogether. Okay, and if I use my calculator here, I'm going to group the top in parentheses, so we'll do 32 plus 37 in parentheses, and then we'll divide that by the 106 plus the 107. That gets me about, let's call this 0.32, that 3 should round up to a 4, although let's take it out to 4 decimals, so 0.3239. Okay, now that we have that, I can actually plug these into my test statistic formula. And that is, I'm going to subtract P1 hat minus P2 hat. So that'll be 0.19 minus 0.3458 divided by square root of, and now I'm going to use my P bar, and I should go ahead and calculate Q bar while we're at it. This is just 1 minus P bar, and that is going to be 0.6761. So I'm going to take P bar first, 0.3239 times Q bar, 0.6761, divided by the first n, and then plus Same thing on top, 0.3239 times 0.6761 all over N2. And drag that square root and fraction bar over the whole thing. All right, now I'm going to throw this into my calculator. And of course you could use a spreadsheet to do this, but you can also do it in one line on your calculator. Doing these calculations in one line prevents any rounding errors, so it's always a good idea, if you can do it, to throw it all in one line. So now I'm going to divide by the square root and wrap the whole square root in parentheses. So 0.3239. Now inside that square root, other than the parentheses I just did, I don't need any more. Because of the order of operations, everything will be sorted out just the way it's supposed to. 0.3239 times here's Q bar 6761 divided by 107. And now I end that parentheses for the square root. And that's pretty standard in most of these one-line calculators. Okay, and that gets me a test statistic of about, let's call this negative 0.68. If I'm using the normal distribution table on the next step, then the z-scores only have 2 decimals, so that's why I'm rounding to 2 decimals. But before that, keeping 3 or 4 decimals is a good idea. Okay, so now the question wants us to go the p-value route as opposed to the critical value route. So we're going to find the p-value for this test statistic and then compare that to the p-value, that is, to the significance level of 0.05. So I need to find the area to the left. It's a left tail test, so I need to find the area to the left of my negative test statistic here. So I'm going to look up negative 0.68 on my normal distribution table. And that gets me, scroll over here a little bit, that gets me to about 0.2483 as my p-value. So I simply looked up the area to the left of negative 0.68 and I got 2483. Now that is bigger than the significance level. So we know the p-value is greater than, let's call this alpha, my significance level, and numerically that is because 2483 rather, is greater than 0.05. So I'm going to fail to reject the null hypothesis because my p-value is too big. There's too much area to the left of my test statistic. Now, if I'm failing to reject the null hypothesis, I'm going to cross the other one out just to drive the point home. I'm failing to reject the null hypothesis, and that goes with the opposite, which is not crossed out. So that means the opposite is possible given this data. So that means even though the proportion of men was lower, it wasn't enough lower for us to say that will always be the case. So there is not enough evidence to support our claim. So if you want to, let's look at how to find the p-value given the test statistic of negative 0.68 using our spreadsheet. So now I could calculate all these values that I did on the calculator, I could do it in a spreadsheet. And it might make things easier. So p hat 1, p hat 2, and p bar are the sample proportions and the pooled proportion that we found earlier. And maybe, let me give myself a couple more spots here. Maybe one, well, two more. So let's say this is men and women. I'm just going to build myself a little table here. Let's call these cat owners and total. Now the total number of men we questioned was 106 and women was 107. Cat owners for men was, let's go back to my problem, 32 that is, and I believe it was 37 women had cats. Okay, so for the p hat 1, I'm just going to divide the cat owners for men divided by the total for men, and then let's do the same for women. So notice where I had to round before because I didn't want to write all these down, the spreadsheet's going to keep track of all these decimals, so rounding will be even less of an issue now. All right, now for the p bar, I want to add these two, that is the number of cat owners total together, divided by the total number of people together. All right, now I can calculate my test statistic, and I do that by, in parentheses, taking p hat 1 minus p hat 2 divided by the square root function. And now this is p bar, and I can multiply that by q bar, but I don't have to actually calculate q bar. You could if you want. I'm just going to call it 1 minus b7, 1 minus p bar, in parentheses. And I'm going to divide that by the number of men. And then plus, we'll do the same thing again. The p bar times 1 minus p bar divided by n2. And now I can find the p-value by calling the norm.s.dist function and throwing my test statistic in there. Oh, and I should have labeled that the p-value. So 0.2468.